Hello, I'm back after the reflow session yesterday. It got a little late, so I had to go to bed, and I'm continuing today. The reflow was working out kind of okay. There was like 3 or 4 bridges on the microcontroller that I fixed by just using a small nozzle on my hot air station, and basically heating the solder to melting point and just slit it with the X-Acto. So that worked out fine, and I compared it to one of the unpopulated and non-mistreated boards, and that color seems to be, pretty much the same. And my brain thought it had like discolored a bit because of the mistreatment yesterday, but it seems like it's fine. So yeah, yesterday fixed the bridges, just put it aside, and today I was going to continue. I've been breaking up all these pin headers. I'm gonna now go on soldering it. Oh, this one is a bit bent. It's not supposed to be like that. Oh, fixed. And while I was looking over it, I was looking a bit more for shorts. I was actually testing a couple of components. Especially there is 12 volt and 48 volt coming in here. 48 volt is only so I can actually measure that voltage. So there's a voltage divider and into one of the analog inputs. The same with the 12 volt. That goes to the regulators and power board, and it also goes to voltage divider here. And so that's the only part of the circuit I really checked that, okay, the resistor to ground is actually connected, because if it isn't, I'm basically gonna send 12 volt through a 20k resistor into the controller, and should be fine, I guess. The protection diode should save it, but I would rather avoid it, so that part is fine. But in addition to the couple of bridges I had yesterday on the microcontroller, there was another slight issue. So with the modern chip like that, it probably doesn't matter, but I fixed it anyway, because it was actually turned 90 degrees. Oh! So I guess filming and placing at the same time is too hard for me. But so I took out the hot air station, this time with a big nozzle, so I could desolder the whole chip, turn it 90 degrees, put it back on, and of course then I got a couple of bridges again that I fixed, and it should be fine. So what I'm gonna do now, I'm gonna solder the power connector, and I'm gonna solder the in-circuit programming connector, and then I'm actually gonna do some preliminary tests, slowly powering it up, checking that all the voltage regulators are doing what they should do, so I'm not like sending 12 volt into this thing. And when I get it powered up, I'm gonna hook on the programmer and see if I can talk to it. So let's start by finding the couple of headers I need for that. This is the one for the power. I'm gonna use this brick because my Chinese quality anti-static mat probably doesn't like the soldering temperatures too much. It's a complete circuit now. It's on top of the anti-static mat, and I'm not using the wrist wrap anymore now, because I think the board as complete as it is now should be pretty robust. So I'm just gonna nest this one in the middle. And then I'm gonna align it properly, because now it's all crooked. Should be fine. Yeah, then we can actually power it, and if we put in the in-circuit programming header 2, we should hopefully be able to talk to it. So again, I'm just gonna attack one of the pins and then go back, trying to align it properly. So there we go, and oh, that looks... Ah, this looks good, just as it is. Need to mess with that. So let's just go. Sticking this last couple of bits. Oh, come on. There we go. So that's it for now. Regards to soldering. So now I'm gonna actually try to power it up. Take away this. Yeah, so that one can start up. And now here I have these guys from my lab power that is now set to very low current limit. I could short these guys out and see exactly what it ends up at. Oh yeah, still a bit for 500 milliamps. Yeah, let's see what the power supply says the moment I hook this on there. Oh! This one didn't. This one has been demolished. Ah, crap. That one is stick. It's smelted. I mistreated it before. I wonder if I bend this a bit extra, can I make it actually close the jaws? Closing, almost closing now. Yeah, let's try now. Yeah, that seems fine. It doesn't pull any current at all, it says. So I guess right now the LDOs are dropping most of the voltage anyway, so let's start measuring a bit here, see where we're at. So if we go there, and we should now okay. This was in auto standby, I guess. So this should be an output. Yeah, so it's dropped to 3 volt there, 1.9 there, 0.9 there. So let's try to crank it up a little bit more. Voltage side. We're up to 7 volt. Oh, the Wi-Fi module came to life. Let's now quickly check the 3.3. Oh, 3.285. Ah, that's pretty good. I'm not sure if you can see that voltmeter. Can you? No, you can't, of course. Always forget that I need to get this in view. And now let's check all of these. This guy, outputs 6.1, so I guess it's expected. 4.966, looks good. 3.28, yeah, I'm pretty happy about that. And let's just crank it up to 12 volt, which is what it's supposed to run at. And that reminds me, I was actually planning to put some heat sinks on this. Guys, so let's just do the finger test. Oh, it's not even getting lukewarm. Well, that's good. What is drawing so... Oh yeah, I don't have a display on here now. I guess that's where most of the current draw will come from. Backlight on the LCD. Because my prototype is running fairly hot, which is why I actually used 2 regulators, and I made space around them for putting these heat sinks. I'm gonna glue them up there. At least, well, if they stay this cool, I'm not gonna bother, but I have the option. So yeah, checking again. This one should be around 9 volt, 8.86. Yeah, I guess good enough. So I first drop it to 9, then to 5, because I need both 5 volt, and then I drop it to 3 volt. All of that seems fine. Okay, enough with this voltmeter. Jump in, and then let's go try to hook a programmer to it. This is gonna be interesting. Yeah. So there. Now I'm gonna. Of course, you won't be able to see any of this. That's a bit shitty. I should have set up some capturing software here, but okay, you just have to take my word for it. I'm gonna launch the programmer. Right. Program doesn't show up. That's my USB. Oh yeah, there it shows up. And trying to communicate with it using the program and debug interface. Read voltage 0.0 volt. Outside range. Yeah. I guess that would be right. Did I goof up something here? I got this the right way, right? Yeah, this one, the program should turn green when I plug it in, and it doesn't. So there is something very, very wrong here. I wonder what that could be. Oh. I hope I didn't mess up something seriously. I have to go look at the layout again. Yeah, that one should have 3.3 volt on that pin. Should have ground there. Yeah, so why? Okay, then I guess I have to go measure the voltages here. Start looking at yeah, the bottom one there should be, that should hold 3.3 volts. If it for some reason, and it is. So exactly why isn't this programmer picking up that? Is the ground missing? Maybe the ground is missing. Oh, I have to go check. So if I measure between this guy and this guy, I should get 3.3, and I do. Now I'm puzzled. see, is this the wrong way around? I wonder if I goofed up this connections. Very confusing. I need to find the specs for that connector. Let's see. And I think I have the pin out for the in-circuit programming connector somewhere here. That would be a bummer. I actually think I switched two pins, which would be really bad. I think those pins are next to each other and the other pin isn't used, so maybe I can just make it like a solder bridge there and I'm good, but that would be really annoying. Yeah, let's see. Here we should have had power there, so I actually screwed this up. Well, that sucks. And that in the middle for the program debugger interface is not used. What was it used for on the other version of this interface? Because the Mega CPUs use a different method of programming where they use all 6 pins on this. The Xmega used the program debugger interface that only used the 4 pins on each corner. And so what I'm gonna do now is I'm gonna actually just short out the 2 pins here, so I get the 3.3 volt that is now in the middle also present on the one in the corner there, and hopefully that will make the program happy. So yeah, let's find some thin copper wire here. This is a tiny tinned wire. Snip a bit of this. Yeah. And I'm just gonna wind that around those 2 pins. I guess I should get the power before doing that. Now the power dropped. Now I'm gonna just... Ooh, that didn't work so well. Try to... How could I make that mistake? Well, I also turned the CPU 90 degrees around, so I guess shit happens. So let's try to just hook this around here. Okay, that got quite a bit tighter. Let's see now. This measure that. Yeah, now it says stable 3.2. Let's see if this guy agree. Still not happy about that. Let me try to actually read the voltage. Yeah, no, it actually worked out. Okay, so that was really annoying. It means I goofed up the programming connector. Luckily that is very easy to bodge. Just need to short off these 2 pins. It should work fine, but oh my god, shouldn't do a mistake like that. What about all the mistakes I made then? Oh well. But yeah, it seems to be talking to it now, and let's see if I can actually program like the set of fuses I need to change. Like I want to turn off JTAG because I use the JTAG pins for other things, so if I leave it enabled the circuit doesn't work. And what else should I set up? Yeah, I guess that should be fine. Clock should be crystal. Yeah. Program. Oh yeah, program the fuses, that's a good sign. Guess it's alive. And yeah, let's try to upload the firmware that I used on my prototype. And see what happens then. Of course that firmware is gonna be really angry because none of its peripherals are hooked up. But yeah, why is it building so much? It's not building. Did it actually flash it? Done building. But yeah, just try again. Yeah. So that's fine. It is talking to the chip. So yeah, let's just hope I didn't goof up too much else rather than that stupid programming connection. So I'm gonna make a more permanent solder joint under the board to fix that, and then solder all the other components on it, and then we can do some more testing. Nothing is getting any hot, warm it seems. The ASP82, no, what is it? 8266. It's usually getting lukewarm, using quite a bit of power. So, but not too bad. Okay, let's hook it down again and turn off the power supply. I'm gonna take off this wire and I'm gonna actually solder another piece of wire across here. Should be fine. Okay, at least it was lucky that the fix was that simple. Still annoys the crap out of me, especially since I have 10 of these boards, or 11. But oh well, I'm just gonna watch this and hope it's fine. Oh well, there, fixed. That should be fine. I guess I should just check that I didn't ground it now, because the only thing insulating that from the ground plane here now is actually the solder mask, which isn't too good. Let's see. Fine for now. Let's hope it stays that way. Yeah, okay. Then I'm actually gonna hook on the rest of the headers here. It was the wrong way. And I'm gonna use this again. There you go. So, it's a debug port. Just hook to the serial, one of the serial ports, so I can debug it using a normal serial terminal on the PC. It's quite handy. Oh, awesome! The pins are just shorter on this dual row header than the single row, so it doesn't really come through here, but oh well. Let's just try this. There's a lot of heat being drawn away by these raw pins. They're all hooked to the ground plane. This is the port going to the inverter board. So it have 4 PWM signals for the H bridge, and I run a ground wire between every other wire to shield it a bit and get the proper ground return. In addition to the PWM signals, there is 2 temperature sensors that use 1 wire each, digital temperature sensors for each side of the H bridge. And what more is there? There's some enable signal for the H bridge, and there's the 12-volt supply for the gate drivers. Well, I guess that's about it. So that is the main duty of this board, is to drive the H bridge, but of course it has a lot of other things to do too, because it have Wi-Fi support, so it talks with the Wi-Fi module. What happened here? Oh my god. I guess I shouldn't talk and work at the same time. Can't handle this. Oh well, fix that one. Yeah, it has Wi-Fi support, so hopefully I'll be able to control the Tesla coil wirelessly, so I don't have to be anywhere close to it when it's actually switched on. And I'm of course worried that the huge amount of RF energy being radiated from the Tesla coil will just render Wi-Fi useless. But so far the tests I've done have been promising. But in addition to the network interface, it of course have a local LCD display and the keyboard and rotary knob interface. So I can actually configure the network and do some control locally. And let's do this guy first. Yeah, and it have piezo buffer, and it has some fan control. It needs PWM enabled fans. It doesn't have the actual, it doesn't PWM the power. I actually bought just some fans that support PWM through a Logic's level signal, and that have tachometer output, so I can read the RPM and control the RPM. So there is some circuitry there for interfacing that. It's not really Logic level. It has local pull-ups, and you control it with open collector or open drain output for the PWM, and it also have an open collector signal for the taco. So there are a MOSFET involved to make an open collector or open drain that can actually tolerate 12 volt. And there is also some circuitry to be able to handle the open collector, basically just a pull-up for the taco. So then in the firmware I implemented a PID controller that can set keep the RPM to a given level, and then there will be also have implemented temperature sensing, so it knows the temperature of the MOSFETs. I still need to implement the actual fan control where it's setting the RPM based on current temperature of the MOSFETs, and also of course all the safety logic there, so it shuts down before it fries and that kind of stuff. So, but I couldn't be bothered with doing all of that before I have the inverter actually up and running. Maybe I should have done it. I have fried it so many times, but it's not because of overheating. I think I have some issues with the gate driver on my first version, so it spikes the gate and kills the MOSFET. So it runs for a while and then it just goes put, gone. I've always been running it on this lab power supply, which is current limited, so when it goes poof, it doesn't go bang, which is a good thing. But I made a new design which should hopefully be more robust in the gate driver section, and I'm waiting for that board to show up in the mail. So at least now I can play around with this controller for a while and finish up the firmware a bit. Seems to be fine. Let's go to the next. This is the first board ever where I actually remember to put thermal relief on any connector that goes to a plane. It makes it a bit easier to solder. It still sucks because of course it has, I guess, 4 or 5 spokes, while a normal pad usually only have 1 or 2 traces going to it, so it still sucks away quite a bit of heat, those that goes into the ground plane. So I'm using a really fat tip on the soldering iron here, so it transfers a good amount of heat. You don't need a fine tip for this, because I mean there's huge amounts of room around these components. There you go. Too many pins. I guess the one I'm soldering now is the display interface. It's gonna hook up to one of those standard character displays, which has 4 lines with 20 characters each. All the special characters are Chinese, I guess. They look Asian, which is a bit annoying because there seems to be multiple versions of them, and some of them have a lot of useful graphical characters in the character ROM, but they have been kind of replaced with weird symbols here. This one. But you have 8 custom characters you can make, so you can usually work around that. There you go, and then we have this is basically a jumper for the enable inverter, so I can move this jumper and disable the inverter. Kind of a half-assed safety feature, so at least the software bug can't start running the inverter, pumping huge amount of energy into something that I might be close to. Another thing I'm not too happy about here is, of course, no, this time I had a silk screen. I usually don't put silk screen on my boards when I made them myself. But here I have this nice, shiny silk screen, and of course forgot to write like this is on and this is off on the jumper. I forgot to print the polarities or the voltages on the power connector. Forgot to mark pin 1, although that is kind of part of the footprint, so I can see what's pin 1 on the headers. Only issue is that the header is covering most of it, but you can actually still tell, so that's good. Yeah, at least I labeled them all, so that's nice, so I can see which header is for what here. But yeah, I can tell that it will be really hard to go back to make my own boards. This is just so convenient, not having to do the drilling, which I hate. And also you get this nice silk screen, which when I actually remember to use it will be very, very useful. The second board I've sent off to be manufactured is the new version of the inverter board, and there I remember to mark a bit more things. I also managed to put some of the markings under pads and stuff, or on top of pads, so they were masked out. That wasn't too good, but it's mostly okay. There's one trying to sneak away here. See, let that fail. Stick this over here. I'm not gonna burn the shop down or myself. So there you go. Yeah, using one of these things to clean it. I got tired of wetting the sponge. Yeah, what are you coming through? Well, I just need to tack it a little bit. I'm gonna fix it. Oh, no. That worked out. Out of the box. Okay. Yeah, I don't like through hole components. Well, I really hated them when I'm making my own boards, because I mean, shitload of drilling, that sucks. But even when I get the board made, it's just so much hassle soldering them. I find it much easier to just drop the pads of the SMD components and reflow it. Much more convenient. touch up this a bit because it was a bit rough with it the first time. There we go. There we go. Yeah, closing in. And here, I'm not entirely sure what's the point of this guy, but I routed out all the power rails to header there, just in case. I also have an expansion port. When I was doing the initial prototyping of this controller, I figured, okay, I needed a fair bit of RAM, because I mean it has network support and it do some DSP, it has audio modulation, so it needs buffers for several things. So this chip has 16K of SRAM, which is very convenient. I mean, 16K sounds like nothing, but for a microcontroller it's quite a bit. While the smaller versions of the Xmega there is a 44-pin version of the same thing, but it only goes up to 8 KB of memory. So in the beginning I was a bit annoyed that I had to go to this huge 64-pin chip just to get enough memory. And then I don't know what happened with those pins, but they disappeared as the design progressed, because in the end I actually ran out of pins on the 64-pin version. So I would like to have some maybe RGB LEDs with some fancy effects running, and I figured, okay, so that's what I'm going to use all the extra pins for. But then I ran out of pins and I had to strip away all non-essential features. So no RGB lights for me. So what I ended up doing was to route one of the SPI buses or ports to this expansion header. So then I can hook up another microcontroller to there, and that can do all the extra fancy stuff. So then that means I don't have to think about it at all right now. Only get the core functionality up and running, and if that's sufficiently successful, then I can go on and implement some other more fancy features on a second board later. Where did I... there is another 3-pin thing. There we go. Yeah, this got a bit messy, but okay, let's try to just hook up the 2 center pins here. Where did it go? Here. Try to straighten it a bit. It's all crooked. That burned my finger. Try to fix the other one. So why is this you getting so hot? It's the neighbor pin I heated. But well, there you go. That's... yeah, I actually have 2 external temperature sensor inputs, so I can hook 2 more temperature sensors to it if I so desire, due to the way that communication implemented in software. I got that almost for free, whether I used 1, 2, 3 or 4 of those temperature chips. That didn't really matter much to the firmware. So And since I had given up on the fancy features, I then had some pins there, so I used them there. Although there was at least one other feature I really wanted to use a pin for that I just had to skip, and that was it was actually two, but they required other peripherals too, like PWM controllers. So I wanted to control the LCD contrast from software, and I wanted to control the LCD backlight. So, but I run out of pins, so contrast is this potentiometer. That sucks, but well, it is what it is. And the backlight is just full blast all the time. None of them are core features of this thing anyway, so guess it's okay. Let's see if I can put this down without dropping this out again. That worked. Tack it. Uncrook it. Yeah, this is the header for the fans, so I can hook two PWM fans to it. Again, wouldn't it be nice if I remembered to mark the connector so I knew which way to plug it in, but oh well. Apparently can't get it all right. Okay, guess that was it for the headers, and then is this thing, so I can tune the contrast for the LCD. Oh, come on, pop in there. There we go. Very close to the mounting screw there, but mounting hole, but should be enough. There, I guess that was it. Yeah, one thing that took me a bit by surprise was this guy, because it had these pads that you solder on there, but they actually have drilled holes in them too, and they ate quite a bit of solder, so it doesn't have much solder left on the outside. They all are connected, I've checked that, and I mean it wicked up there, but it still is well connected there, so I think it's fine. But I probably should have put a bit more paste on those pads, because these were very greedy. But yeah, oh, I guess, yeah, all of that was, yeah, I was talking about that one completely outside the camera, but yeah, the pads here have holes in them, so the paste from the pads down here just wicked up into it, but it still seems to be connected okay. So yeah, now I guess I have to make a cable for my display and have to make a connector for. I still just have the prototype keyboard thingy, so I haven't made a proper keyboard and display board yet. But now I can start playing around with the firmware a bit again and wait for the inverter board to show up. Okay, see ya.